Okay. So I know 7 factors. And from the rational roots theorem, I know that possible solutions are going to be factors of 2 divided by the factors of 1. So just plus or minus 1 and 2. And then I'm going to go look at my graph. So I'm going to type in this polynomial exactly as it's written. So like 25 minutes later, after I type this long thing in, I'm just joking, it doesn't take me 25 minutes to type one of these things into my calculator. It feels that way sometimes, especially when you have to use your mouse to do it. You know, my hands are so much faster. The problem is, like, even the touch screen doesn't work very well on this calculator app and use the touch screen to like touch the buttons. I tried that once, like, oh, this will make it easier. So I typed it in. Now I'm going to reset my window so that I'm going to go like -3 to +3, so a little bit bigger than the smallest and biggest solution for my RRT list, because I just want to be able to see if there's a bend or a bounce or something. I need to see a little bit on either side of it if it's at 2 or -2. So I need a little bit lesser. Okay, so that looks like something there. That looks like straight Arooski. Okay, so here, see how it's on the x-axis for kind of a long time there? I'm suspicious about that. That looks like there may be more than one x-intercept there. So I want to zoom into that spot a little bit more closely. So I'm going to go from like -2 to -1.5, and then I'm going to take my y's from like pretty close to 0. So let's see. What did I say? -2 to -0.5. And then, oh my goodness, we're already super close to 0 here, huh? Well, let's try doing that. Oh, I forgot to write down what that other one was. Confound it. 0.5, wasn't it? You guys were watching. Yes? Okay. Oops. So I'm glad I zoomed in because I can definitely see there's 2 x-intercepts there, right? So I have this one that looks like maybe it's negative. That's right there. And then we have this one at -1. Now, these guys, 1.5 and -1.5, were straights. But -1, see how it's kind of doing that bend action? That's a bend. And I know that these two guys are irrational, and that one's rational, because there's no decimals on my RRT list. So if I make up a list here, total, the bend starts at 3. I have 2 of those. So that's 2 imaginaries, or I could be 5, 2, and 7. I'm not sure those 2 situations I'll be running into, but those are the 2 possible situations. So let's synthetic division and find out what we're running into here. Doing that. So just crank through this division here. Oh my goodness. Why didn't you yell at me when I wrote it down then? Oh, I see. Excuses, excuses. Let's see, we missed the one at x to the 4th. So that's the only one though. Okay. Okay. -4, 4, -11, +11, +2, 0. That's more like it. And I know -1 can be used at least 3 times, so I'm going to just rip through 3 of these divisions right away without really thinking too hard about it. I know it's going to work. Now, if I take a look, I don't like my odds of being able to factor what's left there because it has 5 terms, right? So I'm hoping that I'll be able to get another synthetic division to work on that. But I'm not sure that it will. If it doesn't, we can always come back, take another look, and see if there's some sneaky factoring thing we can enter. And now I know it. There's nothing more to do. X plus 1 to the 5th, because Maddie, how was that?
I think, okay, I did it, yeah. I don't think I did it right. I thought I messed up with the -1.
Oh, okay.
Amount of times that.
Sure. Mackenzie.
For the irrational and imaginary numbers, how do you determine what to put in those first base?
Okay, so 2 things. So the irrational conjugates theorem tells us there are always going to be an even amount of rationals. They always have to come in pairs. Same thing with the imaginary pieces. The complex conjugate guarantees us they're going to be coming in pairs. But I knew the irrationals was 2 because literally from my picture I could see them. There's 2 of them. So that has to be 2 the whole way down the table. The imaginary is what we don't know. Those are invisible to us always. We'll never know for sure if we have them or don't have them. Well, we can be sure sometimes if we don't have them. Like if there's 3 solutions and we see 3 x-intercepts. But in the case where like we don't see everything, we'll never know until we do the synthetic division, finish the factoring, whether there was imaginary ones or not. But those will be the ones that can change. But they're always going to be an even amount of them. You're not going to get odd numbers of them. Does that help at all, Mackenzie? Okay. You're welcome. Eddie.
So then what would you consider like the last question?
So we used it 5 times. So it would have been, we're in the last row of our table.
Yeah.
So so it worked 5 times. So this is the situation that we rolled into.
Oh, and then the last would be considered irrational, not imaginary.
So this piece was irrational because if you set this equal to 0 and solve it, you get plus or minus √2, which is a real result, but it's an irrational number. So those guys are the 2 irrationals that we saw. Because the square root of 2 is about 1.41, which was the values that we saw on the tape or on the graph. Does that feel okay? Alyssa?
And then you said rationals will always be odd. For like, you said that it has to equal 7, and then the one we did like the other day, you had one option was like 2, 4, and the other one was like odd numbers. So how do you, like, is that just
So
rule?
the bend tells me that they're odds.
Okay.
So the bend is an odd number of times it's going to be used, greater than or equal to 3, so at least 3 times, but 3, 5, 7, etc. Bounces are evens, so like 2, 4, 6. Straights are ones. You're welcome. Eddie.
So I get how they would be irrational, and how wouldn't they be?
There's no I. When you solve for x, you don't get an I. So if that was x squared plus 2, and you solve, you get I √2, that's imaginary. But you wouldn't have seen those when we graphed it. Does that feel okay? Okay. Cool. Happy to cover some more questions, but if you'd rather just kind of get started and like I can ask stuff as I'm doing things, you're more than welcome to kind of go at it that route also. By no means do I expect to answer no questions today. In fact, I expect to answer a lot of questions today. Because the things I put on this sheet are like confusing situations. So expect to run into some places where you're not sure what to do or to be confused a little bit. And that's okay, that's intentional. Right? I want to give you some of the weird things that can happen to help develop some intuition so you guys can see firsthand like, oh, if I do that then and this happens, then I know, blah, blah, that's how that's got to work, right? That helps, I think, when you get to see those things happen in real time. Yeah? Okay. Those of you that are working at home, I'm going to drag this assignment into the content library right now that we're going to be working on in class and then sync my notebook for you. So it's not there right now, but it should be there in just a minute or two. So I'm going to do that real quick, and then I'm going to pass these out to the students that are here, or even if somebody like Maddie sitting here in the front wants to pass these out for me, that'd be super spectacular, tremendous. You can do these. You can do this on your own. You can do it with, collaborating with another student or students. Either is fine. Like, I think it really helps to do work on this in real time and get some feedback in real time and compare answers and talk things through and go, oh, what do you do? What did you do for this? I did this, but this is happening. So shouldn't we do that? That's such valuable conversation to have. So there's 4 factoring problems on this sheet. I've intentionally broken them down into like a bunch of different steps where I'm like asking you to use like one thing at a time to answer some question that you'll interpret to get you to the factoring step. So it is 4 pages, I understand. But I've like broken some of these things down in kind of a really specific way, hoping to make it a little bit easier to understand the process. And once everybody has these, there is 2 little edits that we need to make on this packet. So don't dive in too hard, too fast, because there are 2 little edits that we need to make. Thank you, Maddie.